Hello everyone, my name is Visalhounuo. In this video, I'll be explaining on distillation plan. Distillation is the process of separating the components or substances from a liquid mixture by using selective boiling and condensation. Distillation may result in essentially complete separation, nearly pure components, or it may be a partial separation that increases the concentration of selected components in the mixture. In either case, the process exploits differences in the relative volatility of the mixture's component. In industrial chemistry, distillation is a unit operation of practically universal importance, but it is a physical separation process, not a chemical reaction. Distillation is a method used to separate the components of a liquid mixture that depends on the distribution of these various components between a vapor phase and a liquid phase. This requires that the components in the liquid mixture have different boiling points. Another way of putting it is that the component in the mixture must be different volatilities. Volatility is a measure of the readiness of a liquid to vaporize. A liquid with a low boiling point is said to be volatile or having a high volatility and is known as the more volatile component. A high boiling point liquid has a low volatility and is known as the less volatile component. Laboratory scale distillation. Laboratory scale distillation are almost exclusively run as batch distillations. The device used in the distillation, sometimes referred to as still, consists at a minimum of a reboiler or pot in which the source material is heated, a condenser in which the heated vapor is cooled back to the liquid state, and a receiver in which the concentrated or purified liquid called the distillate is liquid state, and a receiver in which the concentrated or purified liquid called the distillate is collected. Several laboratory scale techniques for distillation exist. A completely sealed distillation apparatus could experience extreme and rapid varying internal pressure, which could cause it to burst open at the joints. Therefore, some part is usually left open to allow the internal pressure to equalize the atmospheric pressure. Alternatively, a vacuum pump may be used to keep the apparatus at a lower than the atmospheric pressure. If the substances involved are air or moisture sensitive, the connection to the atmosphere can be made through one or more drying tubes packed with a material that scavenge the undesired air components, or through a bubbles that provides a movable liquid barrier. Finally, the entry of undesired air components can be prevented by pumping a low but steady flow of suitable inert gas like nitrogen into the apparatus. Simple distillation. Simple distillation, the vapor is immediately channeled into a condenser. Consequently, the distillate is not pure, but rather its composition is identical to the composition of the vapor at the given temperature and pressure. That concentration follows Raoult's law. As a result, simple distillation is effectively only when the liquid boiling point differ greatly, or when separating liquid from non-volatile solid or oil. For these cases, the vapor pressure of the component are usually different enough that the distillate may be sufficiently pure for its intended purpose. A cutaway schematic of a simple distillation operation is shown at left. The starting liquid 15 in the boiling flux tube is heated by a combined hot plate and magnetic stirrer 13 via a silicone oil bath orange 14. The vapor flows through a short vigorous column 3, then through a Liber condenser 5, is cooled by water blue, then circulates through ports 6 and 7. The condensed liquid drips into the receiving flux 8, sitting in a cooling bath blue 16. The adapter 10 has a connection 9 that may be fitted to a vacuum pump. The components are connected by ground glass joint. Next is fractional distillation. For many cases, the boiling points of the components in the mixture will be sufficiently close that Rolle's law must be taken into consideration. Therefore, fractional distillation must be used in order to separate the components by repeated condensation cycles within a packed fractionating column. This separation by successive distillation is also referred to as rectification. As the solution to be purified is heated, its vapors rise to the fractionating column. As it rises, it cools, condensing on the condenser wall and the surface of the packing material. Here, the condensate continues to be heated by the rising hot vapors. It vaporizes once more. However, the composition of the fresh vapor are determined once again by Rolle's law. Each vaporization condensation cycle, called as theoretical plate, will yield a pure solution of the more volatile components. In reality, each cycle at a given temperature does not occur at exactly the same position in the fractionating column. Theoretical plate is thus a concept rather than an accurate description. More theoretical plates lead to better separation. A spinning band distillation system uses a spinning band of Teflon or metal to force the rising vapors into close contact with the descending condensate, increasing the number of theoretical plates. Next is steam distillation. Like vacuum distillation, steam distillation is a method for distilling compounds which are heat sensitive. The temperature of the steam is easier to control than the surface of a heating element and allows a high rate of heat transfer without heating at a very high temperature. The process involves bubbling steam through a heated mixture of the raw material. By Rolle's law, some of the target compound will vaporize. The vapor mixture is cooled and condensed, usually yielding a layer of oil and a layer of water. Steam distillation of various aromatic herbs and flowers can result in two products, as essential oil or as well as watery herbal distillate. The essential oil are often used in perfumery or aromatherapy, while the watery distillates have many applications in aromatherapy, food processing, and skincare. Application of distillation. The application of distillation can roughly be divided into four groups: laboratory scale, industrial distillation, distillation of herbs for perfumery and medicinals, and food processing. The latter two are distinctively different from the former two, that is that distillation is not used as a true purification method but more to transfer all volatiles from the source material to the distillate in the processing of beverages and herbs. The main difference between laboratory scale distillation and industrial distillation are that laboratory scale distillation is often performed on a batch basis, whereas industrial distillation often occurs continuously. In batch distillation, the composition of the source material, the vapors of the distilling compounds, and the distillate change during the distillation. In batch distillation, a still is charged with a batch of feed mixture, which is then separated into the component fraction, which are collected sequentially from most volatile or to less volatile, with the bottom remaining least or non-volatile fraction removed at the end. The still can then be recharged and the process repeated. In continuous distillation, the source material, vapors, and distillate are kept at a constant composition by carefully replenishing the source material and removing fractions from both vapor and liquid in the system. The result is a more detailed control of the separation process.